Hello! So, this question, on the face of it at least, seems really wordy. Okay, so good thing to do is get your pen at the ready and underline the important bits. Now, if it's a number, it's usually worth underlining, right? So let's go. There are 1,200 students in a school. I'd underline 1,200. Kate is helping to organise a party. Meh, that's irrelevant. It's just kind of setting the context of the question. She's going to order pizza. Okay, again, irrelevant. It's just setting the context of the question. She takes a sample of 60 of the students at the school. 60 is a number, underline it. So she takes a sample of 60 of the students at the school. So what is this idea of sample, just very quickly? Well, sample, there's two ideas. There's sample, which is what we've got here, and we've got population. Now, the difference between sample and population is that sample is just simply a selection. So if you think a population as a country, okay, everybody within a country forms a population, right? But a sample is just simply taking a selection of people from that country, okay? And that's all a sample is. So in this example, what would the population be? If the sample which Kate selected was 60, what would the population be? It would just be all the students in the school. So the population would just be all the students in the school. And she just takes a sample of 60 people. Okay, she asks each student to tell her one type of pizza they want. The table shows information about her results. So we've got 20 students wanted ham, 15 students wanted salami, 8 students wanted vegetarian, and 17 students wanted margarita. So that's the sample of 60 which Kate ordered. Okay, so work out how much ham pizza Kate should order. Write down any assumption you make and explain how this could affect your answer. Okay, so we just want to look at this column, this row here, because we only want to look at how much ham pizza she has to order. Well, this whole table represents how many students? It represents 60. So if she just ordered 20 ham pizzas and 15 salami pizzas and 8 vegetarian pizzas and 17 margarita pizzas, then that would be enough to cater for 60 students, but she needs to cater for 1,200 students. So in other words, how many more is she going to need? So how many lots of this amount is she going to need if she needs to cater for 1,200 students? Well, the answer is, how many times does 1,200, so 60 go into 1,200? How many times does 60 go into 1,200? That's just 1,200 divided by 60. Cancel off a 0. 120 divided by 6. I can do a bit of cancellation, but that works out as 20. Because 6 times 2 is 12. So 6 times 20 must be 120. Just 10 times bigger. So in other words, I need 20 times each one of these amounts in order to cater for my full 1,200. But I don't want the total pizza in total. I just want to look at how much ham pizza she'll have to order. Well, there's 20 ham pizzas for 60 students. So for 1,200 students, I'm just going to have to multiply that by 20. So in other words, it's going to be 20 times 20. Okay. Well, imagine the zeros aren't there. Imagine the zeros aren't there. 2 times 2, I can do that. That's 4. Then I just stick 1 0 back in. And then I stick the other 0 back in. There we go. So I need 400 ham pizzas. 400 ham pizzas. But look at the second part of the question. Write down any assumption you make and explain how this could affect your answer. Well, I've assumed that that sample is representative of that whole population. So I've assumed that the sample represented in this table is representative of the views of the whole 1,200 students. So I've assumed if we take a sample, then 20 of that sample wanted ham pizza. So therefore, if I then scale that up to represent the whole 1,200 students, that 400 pizzas I would need for 400 of those students would want ham pizza. Okay, so in other words, the sample is representative of the population. So the sample is representative or represents the opinions of the whole population. If that wasn't representative of the whole population, however, so explain how this could affect your answer. If it wasn't representative of the whole population, then you would have more people perhaps liking, I don't know, salami pizzas. So therefore, you'd need more salami pizzas than you'd need the ham pizzas. Because in this sample, the most popular pizza was the ham pizza. But if that wasn't true of the whole population, so when you scale it up to the whole population, the whole population may actually turn out that the favourite pizza turns out to be salami. So in other words, you may need to have a few extra pizzas just in case more people like salami than like ham. So you may need fewer or more pizzas just in case. You might not have exactly 400 people liking ham pizzas. You might actually have something like 404 people liking ham pizzas. So therefore you need 4 extra ham pizzas. So it may be wise just to get a few extra just in case.